Hello, I am a Bullis Student Tutor. In this video, we will be reviewing linear functions. Mathematicians love linear functions because they're simple to graph and easy to read. A linear function is a straight line of the form f of x equals mx plus b. At the bottom of the screen, I have examples of different types of functions. Two of them are not linear. It's easy to eliminate the two that are not linear because they don't have straight lines. Our linear function has a straight line, and as we'll learn throughout the video, it will have the form and equation f of x equals mx plus b. Before we move any further, let's dissect the equation f of x equals mx plus b. In this linear function, it has one independent variable and one dependent variable. The independent variable is x, and the dependent variable is y. Or, as we have on the screen, f of x. B is the constant term or y-intercept, which makes perfect sense because when m equals 0, f of x will equal b. And m is the coefficient of the independent variable. It is also known as the slope, and it gives the rate of change of the dependent variable. As we further learn this topic and translate this function into a graph, we will see and further understand that each variable or term will have a pivotal effect on the outcome of the graph. As I said in the beginning of the video, mathematicians love linear functions because they're easy to graph. I believe the best way to prove this to you is to actually graph a linear function. We will be graphing the function f of x equals 2x plus 1. What you want to do first is create a table of values. Then you want to find 2 points on this graph so you can connect the dots and make a line. So choose any two x values. I'm going to choose 0 for my first x value. If you plug in 0, 2 times 0 is 0, plus 1 is 1. So when x is 0, f of x is 1. My next value I choose to use will be 2. So we're going to plug in 2 for x. 2 times 2 is 4, plus 1 is 5. So when x equals 2, y, or f of x, equals 5. And remember, you can choose any x value you desire to plug into this function. Now let's plot our points. Our first point is 0, 1. Our next point is 2, 5. And our final step will be connect the dots to make your graph. In word for the wise, be sure to use a ruler when you draw your graph to make it as straight and accurate as possible. We can also find the equations of linear graphs by simply looking at the graph. Here we have our linear function f of x equals mx plus b. In order to find the equation for this graph, we need to find the slope, or m, and the y-intercept, or b. To find the slope, we can either monitor the rise over the run, or we can use the formula y2 minus y1 over x2 minus x1 if we have 2 points. Today's our lucky day because we have 2 points, so we can use this formula. Here on the side, we have our 2 points. Let's plug them into our formula. Our y2 is 5. And we're going to subtract it by our y1, which is 1. And we're going to divide that by our x2, which happens to be 2, subtracted by our x1, which is 0. And that will equal to 4 over 2, which is just 2. So our slope is 2. And to find b, which is just our y-intercept, we can look at our graph to see where x is 0. And right here, we have the point 0, 1. So our y-intercept is just 1. So now we found our slope and y-intercept, and we're ready to create our equation. And our final equation will be f of x equals 2x plus 1. Now in the previous example, the y-intercept was labeled on the graph clear as day. But please understand, it won't always be that easy to identify. So this time, I want to introduce a different way to find it, only using a different point than the y-intercept. First, let's choose 2 points so we can proceed in finding the slope. I'm going to choose the points 1, 3, and 2, 5. To find the slope, we're going to do the same thing we did in the last slide. y2 minus y1 over x2 minus x1. And that equals out to be 2 over 1. So our slope is just 2. So we know our slope is 2, but we still don't know what b is. So let's plug our slope into our equation. Also, a quick note, I rewrote f of x as y to make things more understandable as we enter our next step. So now we have the equation y equals 2x plus b, and we want to get the value of b. We need to find something to plug in for y and x, a number value. Now for some of you, a light bulb just went off in your head as you realize that our points on our graph have an x and y coordinate. So we could choose any point on our graph and plug it in to find b. I'm going to choose the point 2, 5. So let's plug it in. Our y is 5. Our slope is 2. Our x is also 2 plus b. 5 equals 2 times 2 is 4 plus b. Inverse operation, subtract 4 from each side. And 1 equals b. And there we go. We're ready to write our equation. So f of x equals 2x plus 1, which is the same as we got before. On the screen, we have 3 different linear graphs, the top of which is the parent function, y equals x. This is the most basic form of all existing linear graphs. In this activity, we are going to compare transform or shifted graphs to the one of this parent function, y equals x. Notice in the parent function, it crosses the point 0, 0, and it has a slope of 1, so it goes up 1, over 1, up 1, over 1. Now take a look at our bottom 2 graphs. This is a transformed version of our parent function. Let's begin with y equals x plus 3. The slope is still the same, but our y-intercept is 3. So, instead, on the top, instead of crossing the point 0, 0, it needs to cross the point 0, 3, which is up here. Since the slopes are the same, the graphs of y equals x and y equals x plus 3 are parallel. Just the graph y equals x plus 3 is shifted 3 units up on the y-axis. In our third graph, y equals 2x plus 0, we kept the y-intercept the same, but we played with the slope. By keeping the y-intercept the same, we made sure that both graphs cross the point 0, 0. By making the slope 2, our blue line is steeper. It rises 2 units and goes over 1 unit, compared to our parent function, which only rises 1 unit and goes over 1 unit. And finally, the domain and range for all linear graphs is all real numbers. This has been a Bullis Student Tutors video. If you enjoyed this video, please be sure to check out the rest of the videos on our page. Thanks for watching.